You've seen how binary conversion works, but can you do it on your own? In this video, I'll show you a practice worksheet I made, go through some of the sample problems step by step, and even show you how you can check your answers. With this worksheet, you will learn binary conversion in no time. Hi, I'm Oliver, a computer science student in my final year. Like many beginners, I used to struggle understanding binary numbers. It feels like a completely different language. But once I understood them, everything from circuits to algorithms became clearer. In this video, I want to give you the tools to get a deeper understanding of them too, and to be able to work with them confidently. You'll get a practice worksheet for your own practice. If you're just starting off with binary numbers, or need a refresher on binary conversion, I suggest you watch my previous videos on binary numbers, especially the one on binary conversion, so that you are best prepared for these practice questions. So first I will show you how you can get the practice worksheet. So here I have an example video where I've shown you where you can get the link. So on the right hand side you see the description of the video. It will look similar to the description of this video they're watching right now. The first link will be the link to the worksheet itself. In this case I've made a demo to show you. The second link will be where you can submit your solutions to check whether they're correct. And the third one is where you can view the sample solutions to see a step-by-step solution for the problem so you can correct your own mistakes. So I'm just going to start off by downloading the worksheet, and this is what the worksheet looks like. There'll be some brief instructions and then the questions. These have the same format as in the full worksheet, where first we have binary to decimal conversion and then decimal to binary conversion. I'll now go through these questions, at least some of them, so you can practice, or rather see how you're supposed to answer the questions yourself. So here you can even see there's a little tip here. This is for the binary to decimal conversion. We see that each digit represents a power of 2 from the right to the left. If this does not make sense to you yet, perhaps you can watch the video on binary conversion again to get a quick reminder. So we have the number 1 in binary, and we should convert it to decimal. I will just do this real quick. So from right to left, powers of 2 means on the right we have power 0, on the left we have power 1. So it would be 2 to the 0 and 2 to the 1. Depending on whether there's a 1 or a 0 in these positions, we either include this number or not in the sum. So in this case, we would get 2 to the power of 1 plus 2 to the power of 0, which would be equal to 2 plus 1, and that is 3. And for clarity, I will write the subscript 10 to know that this is supposed to be a 3 in base 10. This is relevant so that you have an idea what number you're actually representing if its representation is ambiguous. So moving on to the second one, let's just say I make a mistake and say that we start with power 1 on the right. So our sum would be 2 to the 4 plus 2 to the 2 plus 2 to the 1. And we would get 21 in base 10. The reason I'm doing this is so that you can see how you correct your own mistakes by looking at the solutions. The last one I'll skip over for now and just go to the next set of questions from decimal to binary. Starting off with converting 4 to binary, I will just do a quick simulation of the method that I taught last time, which is we divide the number by 2, see what our quotient is, and then what the rest is. So 4 divided by 2 is 2, with the rest 0. Then we move our quotient down here and do the division again and repeat until we're finished. So 2 divided by 2 is 1 with rest 0. Then one more time, 1 divided by 2 is 0 with rest 1. And then we read the solution from the bottom up. So 1, 0, 0. And we write our subscript 2 to know that it's in binary. Alright, I'm going to skip over questions 5 and 6 for now and move on to submitting the answers. So back to the video description. Here I'm going to press on the link to submit the solutions. And you will end up in this Google Sheets quiz. Here for each question there is an entry for the solution. So for Q1, for example, we got our solution 3. And if you read the description here, it says the format that it should be submitted in. It's the number underscore the base. So in our case, it would be 3 underscore 10. For the next one, our solution was 21. This one is supposed to be incorrect to show you what it looks like. And we didn't do 3, we did 4, which we got 100 in binary, so this would be underscore 2. And the rest we didn't do. So you can just fill in the ones you did get and submit it, and then see your answers afterwards. So when you're checking your points, you can see at the top the amount of points you got total. So we got 2 out of 6. And then you can see what you entered and what the right solution is. So in this case, 3 underscore 10 is correct. Here, 21 underscore 10, so 21 in base 10, is incorrect, and you see the correct answer below. And like this, you can test yourself. You see here we got this number 4 as well, and the rest not. And then if you're curious, why did I get this question incorrect? Then you can go to the sample solutions, which is the third link here. And here you can see step-by-step solutions and tips for solving the questions. You can see we have some cheat sheets up here for the binary positions and powers of 2s, and then an example of how you would convert one number. Now, if this is enough information for you, you can continue to try to solve the question again. But if you're still struggling, you can scroll down a bit further and you'll see exactly how you would come to a solution. So, for example, in our case, we got question 2 incorrect. And here we see that the solution is 11 because we have the number 2 to the power of 3 plus 2 to the power of 1 plus 2 to the power of 0. But what we did here was we added 2 to the power of 4 to 2 to the power of 2 to 2 to the power of 1. So our powers are 1 higher than they should be. And instead we should have written 2 to the power of 3 plus 2 to the power of 1 plus 2 to the power of 0, which is 8 plus 2 plus 1, 11. And then these sample solutions just go on with the decimal to binary conversion. Here you can also see again the method that you learned in the first video for converting these numbers, and then the solutions for each of them. When using these solutions, I suggest not to just look at the solution, but try to reproduce the steps to be able to get to the solution yourself correctly. They're here to assist you and to find where your mistakes are and to be able to improve them in the future. So check out the link in the description or the pinned comment with the link to download the worksheet and the solutions. And also don't forget to submit your solutions to see how many you got correct. Keep learning more about binary numbers by checking out my playlist on it. And if you want more practice or help on a tricky topic, drop a comment below. Thank you for watching.